Hello everyone, this is Sri Lakshmi Sivani. Today I am going to explain about data engineering architecture, the fundamental principles. Data engineering architecture is the backbone of modern data-driven organizations. It serves as the critical infrastructure bridging data collection, processing, and the generation of actionable insights. Today, uh, we're going to discuss about the three fundamental principles among the nine principles of data engineering architecture. The fundamental principle the first principle is choose common components wisely. There are mainly three key features of the first principle. First one is team collaboration. Common components facilitate team collaboration, breaking down silos, and enabling agility across teams. The second key feature is broad applicability. Object storage, version control, observability, monitoring, orchestration, and processing engines are broadly applicable for these common components. And the third key feature is accessibility. Common components should be accessible to everyone with an appropriate use case, encouraging reuse and preventing reinvention. In this way, there are three key features for this first principle. The main purpose of the first principle is reusing common components, save time and money rather than reinventing the wheel. Capabilities enabled by common components of first one team collaboration, second one agility, third one broad applicability, and fourth one security. Team collaboration enables collaboration and breakdown silos between teams, fostering a more cohesive environment where agility, shared knowledge, and skills promote agility within and across teams, enabling faster iteration. Broad applicability and security are one of the capabilities of this component. Common components are not just about technology, they are about enabling key capabilities within the data engineering organization. Second principle is plan for failure. The first point is robust hardware. Modern hardware is highly robust and durable, but failure is inevitable over time. The second point is failure consideration. Designs must account for potential failures to build highly robust data systems. Third one, availability and reliability comes under key considerations or key features of this second principle. So planning for failure is critical. Despite the robustness of modern hardware, failures are inevitable. Highly robust data systems anticipate these failures in their designs. Engineers must assess possible failure scenario to plan appropriately. Key metrics for failure planning. There are four key metrics for failure planning. First one is availability. The percentage of time an IT service or component is in an operable state is known as availability. And second metric is reliability. The system's probability of meeting defined standards in performing its intended function during a specified interval is known as reliability. And third metric is RTO, which stands for recovery time objective. The maximum acceptable time for a service or a system outage determined by the business impact is known as RTO. The last key metric for failure planning is RPO, which stands for recovery point objective. The acceptable state after recovery reflecting the maximum acceptable data loss during an outage is known as RPO. So these are the four key metrics for second principle. Architect for scalability is the third principle, whereas scale up handles significant quantities of data by temporarily increasing capacity, where scale down reduce cost by automatically removing capacity once the load spike subsides. Elasticity dynamically scale in response to load, ideally in an automated fashion. By summarizing it, scale up allows to handle extreme loads temporarily, whereas scale down to cut cost when the load reduces. Where the third one, an elastic system can scale dynamically in response to load, ideally in an automated fashion. These are the three principles of data engineering architecture. Thank you.